Time is a very odd creature. Let's go on a deep voyage to understand it. Before Einstein, most people believed that time was a universal being, like a giant invisible clock measuring the entire universe. They believed that 1 minute passing on Earth was the exact same as 1 minute passing on Mars, or in another galaxy, or on an alien planet. In those days, everyone also believed that gravity was just a simple force of attraction between two objects. Even the greatest scientist of all time, Sir Isaac Newton, believed that. Then, a 26-year-old patent clerk named Albert Einstein came along and completely shattered our understanding of reality. He realized that space and time are not rigid. They are flexible, stretchable, and completely relative to who is observing them. He gave us two theories that shook modern physics and changed how we see the universe we live in. But these theories are notoriously hard to wrap your head around. In fact, most people still don't fully understand them today. Let's start with the first one, special relativity. This one is absolutely mind-blowing. The first fascinating thing about this theory is that it tells us true absolute motion doesn't actually exist. Yeah, no absolute motion at all in the entire universe. Even if you travel from your country to another country and come back, Einstein opposed Newton's great theories by proving that there is no true background motion to the universe. And it actually makes perfect sense when you relate it to daily life. Imagine this. If there is only one rock floating in an entirely empty universe, you cannot tell if it is moving or sitting perfectly still. Even if there are two rocks, you can only tell if one is moving by taking the other rock as a still reference point. The reference frame is everything we use to determine motion. To break it down even more, imagine your bedroom is suddenly teleported into the deep void of space. You might be flying around and around at 1,000,000 miles an hour, but you wouldn't feel it. You couldn't tell where you were going or if you were moving at all, until you looked out a window and compared yourself to another constant object. Basically, Einstein is explaining that the reality for a guy standing still on a platform watching a train go by is completely different from the reality of the passenger sitting inside that running train, which is also different from the reality of a guy standing on the roof of that train. There is no single true reality. It is all based entirely on reference frames. So, if motion is completely relative, and your reality is totally different from the guy on the moving train, what is actually real? Is there anything in the entire universe that all of us can agree on, no matter how fast we are moving? Einstein said yes, there is exactly one thing: the cosmic speed limit, the speed of light. This is where the theory goes from slightly confusing to absolutely mind-shattering. Imagine you are standing on that train platform, and the train zips past you at 100 miles per hour. If a passenger throws a baseball forward at 50 miles per hour, your basic common sense tells you that ball is moving at 150 miles per hour. Simple math, right? You just add the speeds together. But light refuses to play by our common sense rules. If that same train is flying past you at 99% the speed of light, and the passenger turns on a flashlight, you do not see that light moving at 199% the speed of light. You see it moving at exactly the normal speed of light. And the passenger on the train? They also measure it moving at exactly the normal speed of light away from them. No matter who you are, no matter how fast your reference frame is moving, the speed of light never, ever changes. But wait a minute. If the speed of light is completely rigid and unchangeable, something else has to break to make the math work. And that something is time. Because light's speed is constant, time itself actually slows down for the person on the moving train. It's called time dilation. If you were to launch your friend into space on a rocket moving near the speed of light, for what felt to him like 5 years, he would return to Earth to find you and everyone else had aged 50 years. His clock literally ticked slower than yours. He didn't just go on a space trip, he time traveled into your future.
And it gets weirder. Not only does time stretch, but space squishes. If you watched that same rocket fly past you, the physical ship would look squashed, like a soda can getting crushed. But to your friend inside the ship, his reality feels totally normal, and you look squished. This is the beauty and the terror of special relativity. Einstein proved that there is no universal clock ticking in the background of the universe. There is no universal ruler measuring distance. Your time and your space belong entirely to you, and they depend entirely on how fast you are moving. And here is the craziest part. All of this, the slowing of time, the squishing of space, the relativity of motion, was just Einstein warming up. Special relativity only applies when things are moving perfectly smoothly at a constant speed. But what happens when things speed up, slow down, or crash into each other? What happens when gravity gets involved? 10 years later, Einstein answered that question and broke our understanding of the universe all over again. But to explain how he turned space into a giant, invisible trampoline, you'll have to wait for the next video, where we dive into the masterpiece that is general relativity.
Make sure to subscribe so you don't miss it.